Today we'll be covering the 2018 rule changes regarding secondary containment, interstitial monitoring, mainly focusing on sump testing and sump repairs and some of the standards and resources that you can use to address sump failures, and also going over the different various methods of sump test methods and sump test protocols. So there's the introductions. Mark has already covered those. Not sure if Don will be able to join us today, so I will do my best to answer any questions, and if not, we can forward those on to Don, and I'm sure he will be back in touch with everyone very quickly. So what is a containment sump? Our definition of a containment sump is a liquid-tight container that protects the environment by containing leaks and spills of petroleum from piping dispensers, pumps, and related components in the containment area. Secondary containment and interstitial monitoring, monitored UST systems, the sump is considered part of the release detection system. So I think it's very important, whenever we go into looking at the topic of sumps and sump testing, is to really understand, the different terminologies and references of a sump. If it's just a regular plastic container in the ground keeping gravel away from, say, an STP head, is that really a sump? As we see in this first picture here. A little arrow. No, that's not really watertight. It's not liquid tight. This is a design sump, but as you can see, there's water intrusion coming into that sump. So it's not truly serving its purpose as a portion of the release detection system, specifically, either containing the petroleum, any petroleum that could be released, or keeping the water out of that sump. So I think it's important whenever we talk about sump, we talk about containment sumps, we talk about sump testing, that you realize that we're talking about a segment of the release detection system. It's just as important as a probe to an ATG, or a leak detector for pressurized piping. It is a component of the release detection system, and it has to work properly. And it has to be properly maintained in order to perform that release detection method. Having some trouble. Sure. There we go. Okay, sorry about that. So containment sumps, again, are used for interstitial monitoring of piping. They can either be single-walled or double-walled with a dry interstice, and periodically monitored at least once every 3 years, or tested once every 3 years to ensure that the equipment is liquid tight. Here in Tennessee, we see most of our sumps are single-walled. Most of them are polyethylene. We do see some fiberglass sumps. Rarely do we see a double-walled sump that's being interstitially monitored, but they do exist. But primarily, most of our sumps are single-walled. So this rule states that if you're not, periodically monitoring it with through interstitial monitoring, then you must ensure that the sump is liquid tight by testing it every 3 years. There's a lot of different test methods, test mediums. You can use a vacuum pressure. Liquid testing, hydrostatic testing is probably by far the most common form of testing. And then, you also have some of these heavy fog air type tests, such as the dry sump testing method that we have seen some people in Tennessee starting to utilize. So the requirements of performing these tests are set forth. You have to use a test method or a test procedure that is developed by the manufacturer. and follow their requirements, or you could, follow a code of practice developed by a national recognized association, independent testing laboratory. We utilize PEI's RP1200 as a great document. All of the testing procedures that I'm going to go over in this presentation is based upon the most recent version of RP1200. We also, in our standardized inspection manual chapters, we also have test instructions, guidance that is, very closely follows RP1200, available in those chapters along with our test forms. And then, also any requirements determined by the division to be no less protective of human health in options A and B. So this kind of sets forth the, I guess, the boundaries of the testing procedures and the test methods that that contractors will need to utilize to be able to perform a legitimate, valid sump test. So, and I've gotten this question a lot, and it seems to be a very common misunderstanding that all facilities that have a containment sump have to perform this 3-year integrity sump testing. That is not true, and it goes back to what I spoke about earlier, where the sump is part of the release detection method, so therefore it has to be liquid tight. So if you're not using interstitial monitoring for piping release detection, then you don't have to perform a 3-year sump integrity test. But if you are using interstitial monitoring for piping release detection, either because of the voluntarily or because your system was installed after July 24th, 07, then you will have to perform this interstitial, this sump integrity testing for all of your sumps, STP sumps, any dispensers, any transition sumps. So the integrity test should be performed prior to October 13th, 2021. That's whenever all these facilities, this rule goes into effect for Tennessee facilities. The tests need to be performed by an acceptable method, and we'll go over some of those methods in a moment, and also be performed by a qualified person. And again, facilities not using interstitial monitoring for piping release detection do not have to perform a sump integrity test. I've been trying to get that out to different owners and contractors, because there does seem to be a little bit of confusion on just because you have a sump present doesn't mean you have to perform this 3-year test on the sump, only if you're utilizing that sump as a component of release detection, i.e. Interstitial monitoring. Also, a new requirement is that all electronic release detection components must have an annual operability test, and the results of those tests must be retained for 3 years. So this includes sensor function tests, which we required those before. Moving forward, owners and operators will be required to keep the previous 3 years of those tests. So, in 2024, ideally that owner will have the previous 3 years of his sensor function tests. Also, this is not in the slide. Also, including in this annual operability testing of release detection components is your annual operability testing of your ATG. And next week we're doing our presentation on release detection. So we'll go over in more details the requirements of the annual operability testing of an ATG, but that is also required if you're using interstitial monitoring to be performed annually in addition to your sensor function tests. So in this, since it's kind of geared for contractors, and a lot of this may be common sense and these resources, but I thought it was good to highlight different areas and different resources that you can go to if you have questions on testing, you know, whether it be sump testing or, you know, spill bucket testing, whatever, you know, different tools and resources you can go to make sure that you're doing these tests correctly, and they're valid and they're meeting, you know, the recommended practices or standards developed. So obviously, probably the most popular form of containment sump testing is a hydrostatic test method. And this is just kind of a real quick snapshot of RP 1200's test procedure. Kind of wanted to go over it because there are some different situations, and I put together some diagrams. I'm a visual person, so hopefully that'll kind of help on performing these tests, especially if you haven't performed a sump integrity test before. You know, to make sure that you're doing these tests correctly and that they're valid. So initially, you want to make sure that the sump is clean, especially with the disposal of sump water. You know, that's kind of a big sticky subject with a hydrostatic test method is what are we going to do with this contaminated test water, taking it from site to site disposal of that. So you want to try to make sure that you minimize the contamination of your test water as much as possible by making sure that your sump is clean and you've removed, you know, as much petroleum residue as you can before, you know, filling it full of water. You also want to do a visual inspection of the sump, you know, all of the boots within the sump, for visual damage. Obviously, if you've got a big tear or a crack in the bottom of your sump or sidewall of your sump, you know, you can fail that sump just by a visual inspection without even, you know, filling it full of water. Obviously, if you've got a big tear in a boot, you know that sump's probably not going to pass. So you would want to address the visual damage before, you know, performing your hydrostatic test. So if everything is visually sound, you'll want to add the water up to the sump to a minimum 4 inches above the highest joint or penetration fitting. So that means that you've got the level 4 inches higher than that highest joint or penetration fitting. So if the highest penetration fitting is less than 4 inches from the top of the sump, you'll want to add water to 1 inch of the top of the sump. And I've got diagrams for each of these, which that's probably pretty rare, but you know, there may be some real shallow sumps out there where that's the situation. You want to compensate for sump deflection, especially, you know, if you're putting a lot of water in. So once you get the water to your appropriate level, you'll want to wait 15 minutes just to kind of let that sump stabilize, to account for any sump deflection, before you begin your test. You'll want to properly place and secure a measuring stick to the lowest point of the sump and measure the water level to the nearest 1/16 of an inch. So PEI says that you're leaving that measuring stick in the sump, you know, secure, for the length of the test. You're not taking a ruler, sticking it down there, saying, okay, it's 25.5 inches. We'll come back and we'll stick that measuring stick back in the same place, you know, an hour later and see. Their method actually shows you're leaving that measuring stick in the sump for the duration of the test. You wait an hour, and then you measure to the nearest 1/16 of an inch again. A loss of 1/8 of an inch or more indicates the fail of that sump. So it's not greater than 1/8 of an inch, it's 1/8 of an inch or more. So it's important to remember that number. Again, here are some diagrams that I put together. Here on the left is a operating sump kind of setup. You know, you've got your sensor in the bottom, you've got your penetration fittings here. So what you'll want to do is, you know, measure up 4 inches from your highest point, clean your sump, you know, fill your water up, and ensure that, you know, the important thing is you want to make sure that all these openings, test boot openings, anything like that is closed off before you perform this test, or else you're going to lose water, through one of those openings. So you want to ensure that all of those are nice and tight before you fill the sump full of water. Take your measurement to the nearest 16th of an inch, wait an hour, come back, take your second measurement. Hopefully it's the same. You haven't lost water. But if you've lost an eighth of an inch or more, then that sump will fail, and you'll have to try to figure out where you're losing that water from. And this is a deep sump scenario where you're not having to deal with the penetration fittings being within 4 inches of the top of the sump. This is a shallow testing scenario. Again, it's essentially the same, but as you can see here, you're filling that sump full up to an inch to the top of the sump, just to make sure you can maximize the head pressure and the testing surface area of that sump to make sure that it is indeed tight. Same test time applies, same readings apply. 16th of an inch measurements, anything of an eighth of an inch or more loss will indicate a failure of that sump. These are our hydrostatic sump testing forms, test report forms. As you can see, they're still drafts. They are still drafts because they're part of our standardized inspection manual chapters, which are in the final stages of being approved. We have approved our walkthrough forms, our monthly and annual walkthrough forms, but I realized yesterday that these are still actually draft because they're part of our standardized inspection manual. So we hope to have those finalized shortly, but again, I don't think there's going to be any major changes to these forms. So it's important to fill these forms out properly. If you have any questions, on the forms or the test procedures, refer to our standardized inspection manual, chapter 3.4, that outlines sump testing and everything secondary, containment, and interstitial monitoring. As with all of our forms, we do have instructions at the top that kind of outline how the form should be completed. It's important that you put all the information that we ask, the facility name and the ID number, owner, all the tester's information, and also do a really good job of explaining sump locations, making sure that you put the product name of, say, the STP sump or the dispenser number with a dispenser sump. So that way, whenever we look at it, we know exactly if there is an issue, where that issue occurred. Go through again, you want to make sure that you clean the sump prior to testing. You want to make sure that you're following the correct level above the highest penetration fitting. Record all this information. Again, you want to bring over your sump locations here on the next page. And just make sure that you have you fully complete this test. And most important part is put your signature and also the test date, because this test is going to be valid for 3 years. So you want to make sure that it's done correctly and it's complete, and everything's filled out appropriately. In addition to the general 1-hour hydrostatic test, there are some testing systems that are out there that allow you to perform a hydrostatic test in a much quicker amount of time, and also test up multiple sumps at a time. These are all still based on a hydrostatic principle. They're just using a more high-tech ruler, essentially. With our new rules, we do require all of our test systems, release detection methods to be NUI-Glide certified. So I've gone through and pulled out the NUI-Glide certified sump testing systems that have been approved, and kind of highlighted these. I think they're all essentially kind of based on on the same principle. You just have, you know, your Ford, Mercedes, Chevys of the different types of systems. They all use a magnetostrictive probe to measure the rise or the drop of the fuel level in the sumps. The test times vary a little bit. The number of tests or the number of sumps that can be tested may vary a little bit. But as you can see, you know, the test times are on average much quicker than an hour. They're still kind of using a lot of the PEI or P1200s, you know, preps of the sump, you know, liquid levels, that type of thing. So Incon has a system. Hydrostatic has a system also that works off this magnetostrictive probe. There's also vacuum test methods that utilize a vacuum on the sump, a vacuum and a surfactant. The deep leak differential pressure leak test is a NUI-Glide certified vacuum / visual method. The benefit of this method versus, say, a hydrostatic method or some of the other sump test methods is that you actually can identify the location of your leaks using this method, where the other ones it's a lot more qualitative of, well, it's the sump's either leaking or the sump's not leaking. Now we have to try to figure out where it's leaking. So this method essentially, yes.
If I could break for just a second. Have David McCamey. His concern is about valves to be removed from secondary piping. If the valves are not replaced or blocked, the hydrostatic test will fail due to liquid entering the secondary piping. Do you have any thoughts on that, or is that kind of a Don question, or?
Well, yeah,
anything
you know, and that goes back to you know, your sump preparation. You want to make sure that, you know, it's kind of one where whenever you're in your normal release detection method, you want to make sure those valves are removed so that, you know, if you do have a leak, it can accumulate in the sump. But whenever you're performing your hydrostatic test, you want, you know, it's kind of the opposite. You want to close that pathway off. You know, it's important that you close those entry points off because, you know, you could have your water, you know, migrating into your piping run that could indicate a fail of that sump. David, is that kind of what you're saying, or did I miss it there a little bit?
Yeah, it's there. When we first saw that the state of Tennessee was requiring the Schrader valves to be removed to prove that there was hydraulic conductivity for your release detection, it's a great idea and it needs to be done. But at the same time, when you go to a site to conduct the 3-year hydrostatic test or any test, I guess, you have to spend several hours reinstalling a lot of Schrader valves. And then of course that is a cost to, you know, your client and, you know, in the regulatory community. So I was hoping that maybe at some point there might be a discussion that could require an annual test, you know, to prove that the Schrader valves are open rather than removing them. And then maybe a question on your hydrostatic test to confirm that the tech reopened them after his test, rather than spending several hours rebuilding every containment, you know, and having to cost that client those dollars.
No, I think that's an excellent idea. I think, yeah, that's definitely something, Mark, that we would probably want to forward on to OCC committee and the Dawn. because that's something that we
Mhm.
haven't
We
we
will.
haven't really faced, and these nuances that you experience whenever you have to do something that you didn't have to do before. A lot of times, previous practices, you know, aren't really best practices anymore. So I think that is a fantastic idea, David.
Yeah, it's a great suggestion, David, and we'll take it to our committee that works on this and see what we can do with it. But I appreciate you pointing that out. So.
Thank you.
Thank you, David. Thank you,
Any other
Matt.
questions, Mark? Questions, comments coming in?
That's all I've got for right now, I believe. So
Okay.
let me double check just real quick. Yeah, looks like we're good. Thank you.
Okay. Yep. And again, thanks, David. That's excellent information and feedback. So getting back to the various different test methods, again, I've not seen this test performed in Tennessee. That doesn't mean that there's not some contractors out there performing this test. But again, a benefit of it is, there is a camera that is put into the sump whenever they pull this vacuum and apply a surfactant to the wall. So as you can see in these pictures here, bubbles will develop where there is leaks, and if you have a repairable sump, then you can do the necessary repairs to where if you are using, say, like a hydrostatic method, you may not be able to really ever determine where that sump is leaking, especially in some of these smaller leaks like you're seeing here in the middle and to the right of the page. So that is one of the benefits of performing this method over the hydrostatic method. And also, you don't have the challenges of hauling and disposing of large amounts of test water is another benefit of this method. Dry sump test method. This kind of came out of left field a few years ago. Whenever I first saw it, I thought, wow, this is wild. But it did go through and get NUI Glide certified. I do know of at least one contractor in Tennessee that has bought this test method. I've not actually seen it used in person yet, but the idea behind this dry sump method is it uses a heavy aerosol, almost kind of like a fog machine, from what I understand, instead of water to test sumps and spill buckets. So vapor ports are permanently installed in the backfill, around your sump, around spill buckets. And this heavy vapor is introduced into, whatever your vessel you're wanting to test, a sump or spill bucket. And then vacuum is applied to the vapor ports that are into the matrix or the backfill material around the sump, and it pulls soil gas into a viewing chamber, which this gentleman here on the right is looking into. And so within that viewing chamber, there's a laser that is on. And so if any of these aerosol particles are pulled through the soil gas into this viewing chamber and refracts that laser, then it indicates that the sump is failed. So a few of the benefits, that the manufacturer suggests is that, once these vapor ports are permanently installed, then you can perform a sump test in just a matter of minutes. What we don't know is the longevity of these vapor points. Are they going to still be functional 3 years down the road? That's time will tell, I guess. Also, again, you don't have the issue with the disposal of sump water, test water, with this method. So again, this method won't show you exactly where your leak is occurring, like you get with the with the vacuum test, but it is another test method outside of the conventional hydrostatic testing that, you know, I wanted to kind of highlight all the tools in the toolbox here today. You know, just so everybody can kind of be aware. So this is a unique test method. I hope to see it performed in the field soon, because it does look interesting. Lastly, I wanted to highlight low-level sump testing requirements. And I put this last because, you know, for a site to perform low-level sump testing, they must apply and receive site-specific approval by the division to utilize this low-level test method. So that means, you know, the owner will need to contact us, say, you know, I want to perform low-level testing at my facility, and you know, this is the reasons why, and then, you know, that will go through. I believe Don approves those. That will go through Don's approval, and you know, that facility will be approved to utilize this test method or not, depending upon, you know, site-specific reasons. So if a site is, you know, allowed to perform this test method, you know, there are additional stipulations that apply that have to be documented and tested during the 3-year test. Most importantly is that the sensors must be programmed to both alarm and provide shutdown. And so that applies to all the piping connected to MPDs. It must shut down the STP for every UST associated with that multi-product dispenser. So if you've got, you know, regular, premium, and diesel all run into all of your MPDs, all of those must be programmed to shut down in the case that fuel's detected. Just because, you know, we haven't come up with sensors that can say, oh, well, this is diesel fuel, this is, you know, this is this is E10 87 octane. So that is the idea behind that, is that the sensors, they don't know what products has been released. So on the side of caution, you must shut down all of those USTs, all those pumps. The only time that dispenser shutdown is allowed in the case of low-level sump testing is if that dispenser is a single product dispenser at a manned facility whenever the pumps are operational. So if you have a standalone dispenser, then that shutdown of that one dispenser is allowed. But for most UST setups, where you're having multiple products dispensed through multiple dispensers, then you're going to have to do a shutdown of your STPs associated with those dispensers. A sensor function test needs to be performed at the time of the low-level testing. The good news is then that this can, you know, be used for your annual sensor function test that we require through the operability testing of electronic release detection components. This test and the subsequent test will need to be kept, annual tests will need to be kept for 3 years. So this doesn't mean that you only have to perform an annual sensor test every 3 years with your low-level sump testing. It means that, you know, you should perform that annual sensor test at the time of your sump testing, but you'll still need to go back out and perform that annual sensor test again, you know, 12 months later, and keep the last three copies of those tests. The low-level sump testing procedure, again, a lot of this will follow along closely with your normal hydrostatic sump testing. You'll want to clean the sump, visually inspect the sump for damage or liquid. You know, obviously, if you open the sump up and there's liquid present, hopefully you would already know because your sensor is in alarm. But you'll want to try to investigate where that liquid source is, whether it be surface water flow or groundwater intrusion. You'll want to make a mark or measure up on the sump wall 4 inches above the sensor activation level. So obviously you want your sensor placed at the lowest point of the sump. So in reality, you're probably going to be looking at 4 to 5 inches above the bottom of the sump. And you'll want to fill the sump up with water to that 4-inch mark. Wait 15 minutes before beginning the test. And I didn't mention this in the other test methods. If there is some sump deflection and you notice that your water level drops a little bit, you need to add some more water to reach that 4-inch mark, whether it be above activation of the sensors, or above the highest boot, or within 1 inch of the sump. Obviously, if you're having to keep adding and adding water, it's probably not sump deflection. You've probably got a leak somewhere in your sump. But if you do notice a little bit of drop, you need to add water to make sure that you're initiating the test at that appropriate level. Again, you'll want to place and properly secure your measuring stick to the lowest point of the sump. Measure your water level to the nearest 16th of an inch. Again, it's a 1-hour wait time. After that 1 hour, you'll want to record the level again to the nearest 16th of an inch. A loss of 1/8 or more, just like the other test methods, indicates a fail of that sump. Again, here is a little diagram I put together. Here's your sensor, and this is your normal operating condition. Your sensor, you want to make sure that you measure up from the level 4 inches above, at least 4 inches above the activation level of your sensor, and fill your water to that level. Secure your measuring stick, make sure it's vertical, and record that measurement. Wait wait an hour, and then record that measurement again. And then, obviously after you're testing all these test procedures, you want to return the sump back to its normal condition. As David alluded to earlier, you are probably going to have to, especially in, your normal test scenarios where you're covering up all of these penetration points, you're going to want to loosen any bands that you've tightened around maybe the outer wall of piping coming in. Make sure that your Schrader valves are opened or removed, and so you have that hydraulic conductivity from your piping to your sump. Because if you don't do that after you perform your test, you really are not performing release detection again, because all these components have to work in unison to be able for this to work. The sumps have to be tight. Your piping has to have communication with the sump. Your sensors have to be properly placed. So if one of those pieces of the puzzle aren't properly configured, then your release detection, you're not performing release detection as you should, and you may miss a release. And not detect it, or you may not detect it as quickly as you normally would, say, if everything was properly configured. Again, this requires division approval. It requires division approval prior to using this method. So if you're interested in applying for this approval, it is a process. You'll need to contact Don Taylor and have justification of why your facility or this facility needs to use low-level testing, and why it can't use the traditional testing methods that I outlined earlier. This is our 3-year sump testing form. It's very similar to our normal integrity test form. Again, here on the instructions, we do require written pre-approval for this procedure before for conducting this procedure. A lot of the questions here are the same. some of the questions are different from, you know, obviously, you know, the shutdown. You know, what actions are taken whenever the sensors do alarm? You know, can you prove positive shutdown? Is it providing positive shutdown to all of the STPs associated with that dispenser? But outside of that, you know, all of your sump prep procedures, all of that are the same with the normal hydrostatic testing method. And again, this is, you know, this comes up all the time, and I don't think it's going anywhere. You know, what to do with your hydrostatic test water, disposal of your hydrostatic test water. Unfortunately, you know, our division, we regulate petroleum underground storage tanks and storage petroleum products. We don't regulate water or waste. So the regulation of this contaminated test water kind of falls in between, you know, our division of solid hazardous waste management and our division of water resources. So if you have questions regarding the disposal of this water, you know, we're probably going to direct you to speak with, you know, solid hazardous waste or the division of water resources. You know, there are some stormwater disposals through local municipalities that may be an option. You want to talk to them before. Some wastewater treatment plants may receive locally generated water. I know in a previous presentation, our manager from Johnson City had mentioned this. He, in the past, has worked with closely with wastewater treatment plants and said, you know, that may be an avenue. If you go talk to them before, you know, say, explain to them, you know, what you're bringing to them. You know, they may require some tests to be performed on that water. But once they kind of maybe become accustomed of you bringing that water to them, you know, it may fall into the benefit of their operation of their wastewater treatment systems with, you know, feeding the bugs that they use and so on and so forth. If you are looking for an on-site disposal to surface water, you know, you're going to have to go through the NPDES permit, which is through our water resources division, which is a fairly lengthy permit process. EPA ALS, the technical compendium, discusses options for disposal. And then test water may be taken to some waste oil reclaimers. You know, obviously, any type of oil, you know, waste oil, oil water separators. But probably the best thing for you to do, as Mark points out, is to contact, you know, your local field office. You can contact us, you know, your local UST field office, and they should be able to route you to speak with somebody that can give you some options and some means and methods to dispose of this test water, because, you know, it will be you know, it's going to be a challenge that we're going to face in the future with this testing. So next, I'd like to go over sump repairs. You know, obviously, we're testing all these sumps that have never probably been tested before, you know, or since they were put in, you know, however many years ago. So all repairs, if you do find a sump that fails, all repairs shall be conducted in accordance with the sump's manufacturer's recommendation or a nationally recognized practice or guidance provided by the division. The division recognizes aftermarket repair components from third-party manufacturers that meet UL standards for petroleum compatibility and construction. Non-manufacturer approved sump repair using UL listed components requires division approval. So if the sump manufacturer says, no, you can't repair our sump, but you have UL listed components, and you can come to us and ask for approval of that sump repair. You're going to have to show proof of compatibility and also proof of integrity testing, which is, you know, some form of hydrostatic test or a test along those ways after the testing completion. You know, we want to make sure that these repairs are being done, most importantly, you know, with the appropriate products, you know, that meet the UL standards. You know, we don't want any flex tape or silicone caulk or, you know, whatever you can run down to your local Ace Hardware and pick up. You know, I haven't seen any of that yet, but I'm sure that we will. So these repairs, you know, they are an option, but they have to be appropriately performed and documented. That's the most important thing, is that you can show that you're using appropriate materials to perform these repairs, and you can document that within your paperwork. Any sump repairs must be tightness tested. Again, this is the same thing as integrity tested, hydrostatic test, vacuum test, whatever your test procedure may be, according to the manufacturer's recommendations within 30 days of the repair. Obviously, I think most people will probably perform that test within a couple days. You know, maybe you might have to wait for some repaired components to cure or harden, but it's important that you do go back within 30 days to test that sump to ensure that it is tight. And these repair documents have to be kept for the life of the system. So it's important that you pass on a copy to the tank owner. And within those documents, you want to make sure, especially if you did a repair, that you document that the materials that you use to perform that repair meets, you know, the UL listed components for petroleum compatibility and construction use within a petroleum setting. There are a few standards. Again, I kind of wanted to create this in the mindset of a toolbox for a contractor to be able to go and find resources and go and find whatever information they need for their specific problem that they may be facing. NLPA, Ken Wilcox Association Standard 823, is a standard for preventative maintenance, repair, and in situ construction of petroleum sumps. To my knowledge, this is the only standardized approach to sump preventative maintenance and repair. It does provide minimum requirements for the in situ manufacturing of petroleum sumps at retail facilities. So this is essentially a standard that highlights how to build a new sump within an existing sump. This goes into pretty great detail of using like a polyethylene sump, a felt or cracked polyethylene sump, as essentially a mold to construct a fiberglass sump within that sump. The main parts of this standard, again, is the sealing, caulking of sump seals and penetrations. This standard excludes the application of sealant and caulk to polyethylene sumps. It also provides information on providing a watertight assembly to existing sumps if you're having issues with your sump top. And again, construction in place of a new or single-walled sump without the needed removal of an existing sump. So this standard does allow that a damaged polyethylene sump can be used as an in situ fabrication mold. Some additional sump repair resources: the UL standard for safety outlining of investigation for containment sumps, fitting accessories for fuel covers. This standard addresses containment sumps, tank dispensers, transition fill vent pipe types, sump fittings, penetration, terminal, and terminal test monitoring types, and then also sump accessories, lids, frames, brackets, chase pipe, all that kind of stuff. So that's a good resource there for looking at the UL listings of different components for sumps and associated UST components. UL also has a compatibility tool. This is a website where you can find that. And so if you are looking for make sure that you can show compatibility, which is one of the things that we ask for if you're doing a non-manufactured approved repair, but division, you're requesting division approval for that repair. You know, this would be a good resource to go to prove, you know, your proposed repair, the compatibility of that proposed repair to the sump or whatever you're looking at repairing. SWAMO, well, previously we were the emerging fuels, now we're emerging issues, have put together a compatibility tool on our SWAMO website. Again, it's not quite as in-depth as UL compatibility tool, but again, it's another resource that you can go to whenever you're trying to show compatibility of the proposed repairs to a sump. There are some UL listed third-party repair companies, you know, Icon Containment Solutions, All Seal Sump Systems, and Bravo Sump Systems. You know, we're not trying to advertise or do anything like that. We're just trying to give contractors and, you know, people within the industry different resources and tools to turn to face, you know, the challenges that may be presented with all these sump testings that's coming down the road. So again, I wanted to hopefully maybe expand your toolbox today on different places and resources you can go to try to address these, you know, these sump testing and also potential sump repairs that may come from these sump tests that we're asking owners to perform. Reporting of a repair. So if you go out and you see obviously visual damage or a failed sump, you failed your integrity test. You know, defective equipment must be repaired or replaced. So if you indicate it, if you see a torn boot, you know, if the manufacturer doesn't allow the repair of that torn boot, then that boot must be replaced. Additionally, with a sump. So, you know, again, there's different routes that it can probably take, given how bad the defective equipment is, how bad is the tear, how bad is the crack. But the important thing is that it's repaired and replaced in a timely manner. So in the case of a secondarily contained system, whether it be a sump or, you know, a tank, anything like that, if you're having liquid present in the interstitial space, you know, that must be immediately removed and investigated. You know, in the case of a secondarily contained tank, that is a suspected release, and that should be reported to us within 72 hours. If you're in a double-walled sump where that's being presented is not quite as is not really a suspected release, but in the scenario of a double-walled tank, it is because you've either lost integrity to your inner wall or your outer wall, and you know you're no longer meeting that secondary containment requirement of the tank. Obviously, any unusual operating conditions, you know, this is kind of our catch-all phrase, you know, must be reported within, you know, 72 hours to the division. You know, if you go out and you have a sensor and alarm and you go out and you look and you've got water in your sump, you know, you don't have to call and report that to us, you know, but you do want to remove that water and investigate to see where that water intrusion is coming from. If it's occurring over and over and over, you know, every week or every time it rains, then that is something that you probably do need to contact your field office and say, hey, we've got this issue. What do you want us to do? Likely we ask for an integrity test of the sump and then go from there. Again, this crucial, this last point is that your repair documents include proof of compatibility. Not just that you repaired a sump, you have to show how you repaired the sump and also that the sump after the repair was tight. And those documents must be kept for the life of the UST system. You know, it would be best to, you know, send a copy either to best practice, either to the owner or, you know, if you have a contact at your local field office, maybe forward them a copy. Say, hey, did this repair on the sump. You mind sticking this in the facility file for us? And that way we can go ahead and try to get it filed in our system so we can have it on down the line. That's not required, but again, that's probably best practice to try to get these things on the books, because we all know that UST facilities, once, in my experience, once it's sold to a new owner, all those previous paperwork and reports, don't get transferred. They're lost in time. So if you can get a copy of it to us and we can get it, in our file system, we'll have it no matter, if the site's sold, 3 more times, we'll have that documentation. Again, these are some of the resources I highlighted. There are probably some more out there, but I felt that these were probably the best, most useful resources to turn to. Again, for testing anything related to secondary containment, interstitial monitoring, specifically to Tennessee, please utilize our SIM technical chapter 3.4. This is true for just about any area of our program, whether it be ATG, SIR, spill bucket, overfill prevention. Our technical chapters are a very good resource, not just in the fact that they relate everything to our regulations, but they also just have a lot of good material in there, a lot of pictures, a lot of appendices, charts that kind of explain that area very thoroughly. They still are in draft, but we hope to have those approved shortly. But I would definitely suggest that being your first stop if you're having questions regarding anything with Sump or interstitial monitoring or really any area of the UST world within Tennessee. Our local field office contacts, again, this is on our website. You can also contact me or Mark or any of the panelists on this call, and we can get you in contact with someone in your area regarding whatever problems or questions that you have. This is essentially the end of the presentation. I have here included a link. These are our technical chapters, our current and our updated draft technical chapters of all of our areas on the compliance, operational compliance side of the program. Also, we've issued, every year we issue a UST Compliance Toolbox to owners and operators. That doesn't go out to contractors that I'm aware of. This is a virtual version. We mail out a small USB drive version to all the owners operators, and it includes all of our forms, our copy of our tank school presentations, our SIM chapters, our rules, regulations, any forms that you would need. So that's a good reference there, just to kind of have all of our UST information in one handy little box, is to go and download our compliance toolbox. And we update that and reissue it every year. So, and once we do that, we'll update the one that's uploaded to our website.